Hi, great tops. Welcome back to this channel. Thank you very much for joining us today. And today we're going to be starting with our new sessions on analytical geometry, or what is known as coordinate geometry. Okay. And in this first session, we're going to just quickly start with a revision from your grade 10 to 11, also incorporating this with very key exam kind of question in your grade 12s. Okay, let's start with this quick revision. Distance between 2 points, right? You learn about distance between 2 points, and this is quite fairly very simple. We know that distance formula can be used to determine the length of a line segment, right, between 2 points, or the coordinate of a point when we know its length, right? So we know distance formula. It says if maybe we have point A and B, and we have XA and Y A, XB and YB. All right. So the formula will say AB, which is our distance, is equals to what? The square root of x at B minus x at A squared plus y at B minus y at A squared. Or rather, if you square both sides, you'll have your formula as AB squared is equals to x at B minus x at A squared plus y at B minus y at A squared. So we call that a what? A distance formula, right? It's a formula that we use in order to calculate the distance. Okay, let's quickly move to the midpoint of a line segment. What is, or rather, what do you understand by a midpoint? Okay, so if you have line AB, right, and you have a point in the middle, such that maybe let's call it point M, such that AM is the same as what? Is the same as what? Is the same as MB, right? If AM is the same as MB, then we can actually calculate this midpoint, the coordinate of a midpoint, using this formula. Okay, using this formula. How do we calculate that? You just say M, and your open bracket is equals to x at A plus x at B. So you take x at A plus x at B, you divide by 2. Then you'll have what? You'll have the coordinate of x. Okay, so for you to get the coordinate of y, remember you'll have your coordinate of x here at the midpoint. For you to get the coordinate of y, you take your x at what? Your y at A and your y at B, you add them and divide by 2, because it's a midpoint, it's in between. So you calculate and you get your answer there. Okay, very, very important. What if now, if we have the midpoint and we have one other point and we want to determine the other points? For example, let me just show you quickly, and this is very, very important for you to know. If you have maybe A, you know your x at A and your y at A, right? And your y at A, and probably you have your B, you don't know your B, right? And you have your midpoint, such that this line is the same as this one. You have your midpoint, x at midpoint and y at midpoint. How can you calculate the coordinate of B now? Very simple. What you do is, we know that x at midpoint is the same as what? X at A plus x at B, all divided by what? By 2, because it's in the midpoint. Then also y at midpoint is the same as y at A plus y at B, all divided by what? All divided by 2. So you just simply go and substitute your x at midpoint, your x at A, and you go and solve for what? For x at B, and you get your x at B there. So get your y at B, use this formula again. You go and substitute y at midpoint, because you'll be given, and also y at A, and you go and calculate for what? For y at B. So that's how you do that. All right. Okay, let's now quickly move to the gradient of a line, or what is also known as the slope, right? So you know that the formula for a slope is represented by small letter m, and this is actually the ratio between the change in y values and the change in what? In x values. Okay, so the formula is simple. If you have point A and B, what you do in order to get the gradient, we can say small letter m. Remember, small letter m stands for gradient AB. We can say the change in y over change in what? In x. Okay, so what we'll do here, we can say yb minus y at a all divided by x at b minus x at a. Take note of this. If you say yb minus y at a, also you'll start with what? With x at b, right? So they must be correlating there. Or someone can choose to say y at a minus y at b, then you'll start with x at a minus x at what? X at b. So that's a gradient, and it's also known as a slope, right? Okay, so we also have this idea of collinear points, right? Collinear point. What does it mean when we say points are collinear? That is, they are in the same straight line, right? Collinear points, we are saying points are in the same straight line, such as ABC. What does that imply? It implies that the gradient will also be the same, because if we calculate the gradient of this line at any point, it will still remain the same because it's a straight line, right? For example, if we have ABCD and we know that ABCD are collinear, then we can deduce gradient of AB, that is MAB, small letter MAB, will be the same as gradient of BC, which will be the same as gradient of AC, right? Because they are what? They are collinear. Okay, let's now move to inclination of a line. Inclination of a line. Okay, so you know that they can give you a line, right? And that line might form an angle between the x-axis, right, in an anti-clockwise direction. So that angle that is formed between any line and the x-axis in an anti-clockwise direction is called what? The angle of what? Of inclination. The angle of inclination of that line. Okay, so how do we get that angle? Very simple. You use the formula tan theta is equals to the gradient of that line. Let's just say this line is called, or rather, let's use this one, OR. So this line is OR, right? So meaning that if we want to get that angle, which is the angle of inclination, we'll say tan theta is equals to what? Is equals to gradient of OR, right? It is equals to the gradient of OR. So that's very simple, and that's how you calculate that angle of inclination. Okay, so a lot of students make mistakes. They can give you an angle this side and call it beta, right? And they say calculate beta. So don't make that mistake to say tan beta is equals to gradient of that line, right? It's not the same. Why are we saying it's not the same? Because this is an angle, but in a what? In a clockwise direction. So it's not actually the angle of inclination. So the angle of inclination is the one in an anti-clockwise direction between the x-axis and the line, going to the line in an anti-clockwise direction. Okay, so if they give you this one, calculate beta, what you can do, you first calculate your angle of inclination by saying what? Tan theta is equals to gradient of OR. After getting your theta, then you can use some angles of a straight line is equals to 180. Then you solve for that beta. All right. Very, very important, lines, right? Let's now talk about lines. We know that we have different properties of lines. Lines can be parallel, right? So how do we know that lines are parallel? Very, very important. When their gradients are what? Are equal. So in other words, if lines are parallel, they will have equal what? Equal gradients. Okay. For example, if I have line AB and line DE, if I want to if I want to know if these lines are parallel or not, I can just calculate their gradient, right? So I'll calculate the gradient of line what? Of line AB and the gradient of line what? Of line DE. If they are equal, then I can deduce that those lines are what? Are parallel. Number 2, perpendicular lines. Perpendicular lines. How do we know that lines are perpendicular? So if lines are perpendicular, it means that where they intersect, they form 90 degrees, right? In other words, where they intersect, they must form 90 degrees. If I have AB and my DE, How do I know that those lines are perpendicular? When you multiply their gradient, they must be equals to what? -1. Very, very important. It means that the gradient of line AB multiply with the gradient of line DE must be equals to -1 to prove that indeed they are perpendicular. Okay. Okay, so for number C, we've already discussed that collinear lines. We know that they lie on the same straight lines and their gradient are actually the same. Okay, if we have collinear points. Let's now talk about equation of a straight line. Very, very important. Equation of a straight line. We know that the standard formula for equation of a straight line from function is y is equals to mx plus c, where m is the gradient and c is the y-intercept. Okay, so that's what we know. It can also be represented as y minus y1, which is just any point on your line is equals to m into x minus x1, which is the x value of that point on your line. Okay. All right. Let's now quickly look at this past paper as an example of how we can incorporate all this knowledge in solving this problem. Okay. Okay. Question 1. You are given that ABCD is a quadrilateral with vertices A, B, C, and D, and you are given the points 1.1, right? So for your 1.1, they want you to determine the coordinate of M, which is the midpoint of AC, right? And it has 2 marks. In other words, you have coordinate of M somewhere there, which is actually the midpoint of what? Of line AC. So we know the midpoint formula, right? If we need the midpoint of a line, we just say we take those coordinates and we add them and divide by 2. So we say x at A plus x at C divided by 2, point comma, y at A plus y at C all divide by 2. Okay, because we want to get the coordinate of M, which is the midpoint of AC. X at A is minus 3. X at C is what? Is 2. So it will be minus 3 plus 2, all divided by 2. Then y at A is 0. Y at C is -1. So it will be 0 minus 1, all divided by 2. Then our coordinate of M will be minus 3 plus 2 minus 1 over 2 and minus 1 over 2. So that is our coordinate of what? Of M. 1.2, they want you to show that AC and BD bisect each other. Okay, what does it mean when lines bisect each other? It means that those lines must have equal lines. Okay, they must have equal lines, number 1. Number 2, they must have also equal midpoints. For example, if I'm saying this line, which is BD is bisecting with this line called AC, right? If it has to bisect, it means their midpoint must be the same, or rather they must have equal lines, as I said, right? So this line must be the same as this one. This one also must be the same as that one, right? But the one that is quickest is when they have the same midpoint, right? Then we can deduce, oh, they actually bisect one another. So what we have to do now, remember they said show that AC and what? AC and BD bisect each other. So we already calculate the midpoint of AC. We just need to calculate the midpoint of BD. If it's the same as the midpoint of AC, we can conclude, oh, they actually bisect each other. Okay, so we're gonna calculate the midpoint of BD, right? Midpoint of BD will be x at B plus x at D divided by 2, point comma, y at B plus y at D, all divided by 2. Okay, midpoint of BD will be x at B is minus 1 plus x at D is 0 divided by 2. Y at B is minus 3 plus y at D is 2 all divided by 2. So our midpoint will be minus 1 plus 0 over 2 is minus 1 over 2. Minus 3 plus 2 over 2 is minus 1 over 2 also. Can you see now we can conclude that midpoint of BD is actually the same as the midpoint of AC. Therefore, AC and BD what? Bisect each other because they have the same what? They have the same midpoint. Let's go to 1.3. 1.3, very interesting. They are saying prove that angle ADC, which is this angle here, is equals to 90 degrees. Prove that this angle here is 90 degrees. How can we prove that that angle is 90 degrees? Okay, if that angle is 90 degrees, it means that AD should be perpendicular to what? To DC. So what do we know about AD being perpendicular to DC? It means that, very, very important, we said the gradient, when we multiply the gradient, if these two lines are perpendicular, when you take their gradient, it must be equals to minus 1. In other words, if we can manage to prove that the gradient of AD multiplied by the gradient of DC is equals to minus 1, then we can deduce actually they are perpendicular, meaning there is 90 degrees there, right? So that's a way you can prove that. Very, very important. So we're just going to calculate the gradient of AD. So it will be y at A minus y at D over x at A minus x at D. So what is our y at A is 0 minus of the formula, right? Y at D is what? It's 2. X at A minus 3 minus of the formula. X at D is 0. This will give us minus 2 over minus 3, which is 2 over 3. Okay. Let's go and calculate gradient of DC. It will be y at D minus y at C over x at D minus x at C. What is our y at D? Our y at D is 2 minus what is our y at C? Our y at C is minus 1. So don't make that mistake to say 2 minus 1, right? Because you have this minus for the formula, but your y at C is actually negative 1. So be careful there. X at D is 0 minus what is our x at C is 2, right? Okay, so it will be 2 plus 1, which is 3 over minus 2. Okay, so we're just going to multiply these two gradients of AD and DC, and let's see what we get. So it will be 2 over 3 times 3 over minus 2. This cancel this cancel this, and they're equals to what? Minus 1. We can deduce, therefore, AD is perpendicular to what? To DC, because their gradient is equals to what? Is equals to minus 1. We have just proven that when you take their gradient, you multiply them, is equals to minus 1. And we know that if we multiply the gradients of two lines and we get minus 1, it means those lines are what? Are perpendicular, meaning that indeed our angle, we can deduce, therefore our angle ADC is 90 degrees. Because what? Because AD is perpendicular to DC. We've just proven that. Okay. Okay, let's now go to 1.4. They're saying in 1.4, they're saying show that ABCD is a square, right? So you must know properties of a square in order for you to be able to show this, right? If ABCD is a square, meaning that all these angles are what? Are right angles, and what? All these lines are what? Are equal. In other words, you just need to go and calculate your AD. Let me write it for you. You just go, you are just required to prove that AD is equals to DC, which is equals to BC, which is equals to what? Which is equals to BA or AB, right? If you just prove one of those properties to say all those lines are equal and all those angles are right angles, then you'll be able to show them that it is a square. That's why it's 6 marks, right? So we won't go and just do that because it will take quite some time. You can do that on your own and just calculate the length of AD, DC, BC, and AB using what? Using distance formula. For example, for AD, you will say is equals to root of x at A minus x at D squared plus what? Y at A minus y at D squared. Then you go and calculate and show them that indeed it is x squared. Let's now quickly go to 1.5. Very interesting examinable question. Determine the size of theta, the angle of inclination of DC, correct to 1 decimal place. It's quite a fairly easy question, right? Remember, here we're just revising your grade 10 to 11 analytical geometry. All right, so they want you to determine the size of angle theta, right? Angle theta, and which is the angle of inclination. We know that it's an angle of inclination because it's the angle between the x-axis and the line, and it's an angle that is measured in an anti-clockwise direction. Okay, meaning that our angle of inclination will always be what? Positive, because when we measure angles in an anti-clockwise direction, they are positive. This is 0 degrees, 180 degrees, 90 degrees, 180 degrees, 270 degrees, right? They are positive. What happens now when you calculate the angle of inclination and you find that it is negative? What you do, you must add 180 degrees. Very, very important. If you calculate your angle of inclination and you get that it's giving you a negative, know that an angle of inclination must always be positive. So what you do, if you get a negative angle, you just go and add what? 180. Why adding 180? Because an angle of inclination is always between 0 degrees and 180 degrees. So that's why you have to add 180. Okay, so we're just going to calculate the angle of inclination, our theta there. How do we do that? We know the formula. It says tan theta is equals to the gradient of that line DC. Okay, so we must calculate the gradient of line DC and go so for our theta. Gradient of line DC will be y at D minus y at C over x at D minus x at C, right? So our tan theta, y at D is 2 minus y at C is -1. Be very careful there. X at D is 0 minus x at C is what? Is 2, right? In fact, we had already calculated our gradient of line DC there, and we got it as 3 over -2. But let's just verify again. It's just gonna be 3 over -2. Okay, so that was our answer there. It's also true, 3 over -2. So to solve for theta, we're gonna take arctan 3 over -2, and we're gonna see how much we get. So arctan 3 over -2, it's giving us just wait a bit, it's giving us -56.31 degrees, right? We just said it that an angle of inclination is always positive. If it's negative, what do? You come and add 180 degrees. Then you get your angle of inclination as positive. We say that answer plus 180 degrees, we get 123.7 degrees. So that will be our angle theta, which is the angle of inclination. Okay, great tops. That's all for today. Thank you very much for watching. Thank you very much for joining us in this session. I hope you learned something. And this was just our revision from our grade 10 to 11 analytical geometry. Coming up next, it's your newly added knowledge in your grade 12 analytical geometry. Very, very interesting. We're going to be focusing on the next session on the equation of a circle. Okay, the equation of a circle. Otherwise, that's all for me, and goodbye.